Hey guys, Mrs. Diaz here. We are looking at day 5 of our review. We're going to take a look at homework 5.4.1 as well as homework 5.4.2. So let's take a look. This is applying the power rule, which is finding the derivative. So if you recall, and I don't even have my pen open, there it is. Okay, if you recall, the power rule for the derivative means you take that exponent, you bring it to the front, so it'd be like 4 times 3, and then x, and then you're going to subtract 1 from the exponent. So 4 minus 1 is going to be 3. So 4 times 3, because we brought the 4 to the front, that's going to be 12x cubed. And that's the derivative. Don't forget that the derivative notation is like almost like a apostrophe. So f prime of x is equal to 12x cubed. Okay? If you look at number 2, you're going to do the same thing. We're going to bring the exponent to the front, and you're going to take each piece individually. So it'll be like 10x minus 3. And again, don't forget that notation, f prime of x equals 10x minus 3. Now remember, whenever you have a constant, the derivative of a constant is 0. So that number will go away. If you look at number 3, I can bring x to the numerator. To do so, I would have to make x to the power of negative 1. You have to remember that right now it's x to the first, but it's in the denominator. And to bring it to the numerator, you have to make it a negative exponent. Then we can do the power rule, bring negative 1 to the front, so it would be f prime of x equals negative 4, x to the negative 2, because you subtract 1, negative 1 minus 1 is negative 2, or you can rewrite this as negative 4 over x squared. And that's because you can bring x to the negative 2 back into the denominator to make it a positive exponent. Okay, let's look at number 5. Number 5 is 6 times x square root of x, but that's also saying x to the 1/2. So you need to remember that the square root of x is the same thing as x to the 1/2. You're going to bring the 1/2 to the front, so it's 6 times 1/2. And then you're going to subtract 1, so to the negative 1/2. That should give us 3x to the negative 1/2, or 3 over the square root of x, because it's a negative, and if you have a negative, it goes into the denominator. And remember, the 1/2 is square root of x. And that's for number 5. Alright, let's keep going. So I'm going to go ahead and scroll to see what other kind of examples we have. If you remember in our exploration, we actually did an example like number 9 and number 10. So I want you guys to look back at your exploration to see if you can answer 9 and 10. Now I'm going to go to the next homework. I brought Russo, my puppy, and you want to say hi, bud? Okay, no, he just wants to lick me. Alright, let's continue on. So, use your knowledge of derivatives, increasing and decreasing, to answer the questions. It says a calculator should not be used. When they say that, don't use a calculator. So, let's look at number 1. It says, given the function, this is a cubic polynomial, answer the following. Is the function increasing or decreasing at x equals 2? List the intervals that f of x is increasing. List the intervals that f of x is decreasing. And at what values does f of x have a relative max or minimum? Optional, sketch what you think the graph should look like based on those answers from B through D. So the first thing I'm going to do is I want to figure out the derivative. Alright, these problems we are going to find the derivative, and the reason we want the derivative is because if y'all remember, wherever there's a maximum or wherever there's a minimum, the slope at a max and the slope at a minimum is going to be 0. So if we can find the slope equation, which remember slope is derivative, if we can find the derivative, we'll set the derivative equal to 0. Right, Reese? Okay, let's try it. So the derivative of x cubed is going to be 3x squared. The derivative of negative 6x squared is negative 12x. And then the derivative of 9x is 9. Oh, and don't forget, the derivative of 1 is 0. So we've got our derivative equation. Now we're going to set the derivative equal to 0. So if I set that equal to 0, 3x squared minus 12x plus 9 equals 0. I'm going to factor out a 3 because this has a 3 in common, all three pieces do. Minus 4x plus 3 equals 0. And then we can factor this. So if we factor, there's a 3 still in the front. It's going to be x and x and minus 1 minus 3. Right? Because negative 1 times negative 3 is positive 3. Negative 1 plus negative 3 is negative 4. Set each factor equal to 0. So it's going to be x equals 1 and x equals 3. After we have that information, we're going to almost like put it on a number line. So we're going to have 1 and 3. Once we put those values on the number line, I'm going to actually plug in some values that fall into these intervals. So for example, something that's smaller than 1, that would be like 0. If you plug in 0 into the derivative, you get 0 minus 0 plus 9. Well, that's positive 9, meaning it's going to be increasing between negative infinity and 1. So where is it increasing? Negative infinity to 1. Now there might be somewhere else where it's increasing. Let's keep finding out these values. So let's plug in a value between 1 and 3. How about the number 2? You can plug in 2 into the original derivative, or you can plug in 2 into the factored form. So like 2 minus 1 is 1, times 3 is 3 so far. And then 2 minus 3, well, that's negative 1. And negative 1 times 3, well, that's negative 3. So that means it's going down. It's decreasing here. And that was between 1 and 3. So where is it decreasing? Well, that's between 1 and 3. And then last but not least, let's plug in a value greater than 3, like 4. So 4 minus 1 is 3. 4 minus 3 is 1. 1 times 3 is 3 times 3 is 9. Again, it's a positive value. So it's going to be increasing. Okay, so it's going to be also increasing from this coordinate, 3, all the way to infinity. So now we have our intervals of where it's increasing and where it's decreasing. And then it asks, what values does f of x have a relative maximum or minimum? Well, notice when it's increasing to decreasing, that creates a maximum. So the maximum, and careful, it looks like I'm pointing to the number 3, but I'm pointing to this point, which is at x equals 1. That's where the maximum is. And then the minimum, well, that's where it goes from decreasing to increasing. That's going to be our minimum, which is at x equals 3. And just like that, we have found the max and min. Notice we're not using the picture, we're not using the calculator, but we're using the derivative. Okay? Now, on part A, it does ask if the function is increasing or decreasing at x equals 2. Well, in that interval between 1 and 3, I would say it is decreasing. But you got to be careful because it can't ever be decreasing or increasing at just a coordinate. We need an interval. So it's decreasing between 1 and 3, which 2 happens to be in that interval. But I don't want you guys to think that at 2, at exactly x equals 2, is increasing or decreasing, because we can't really tell what's happening at just one point. One point is just some random point in space. We can't figure out if it's actually increasing or decreasing at just one point. We need that interval. So just kind of keep that in mind. It's kind of like a trick question. Oh, Risa got really excited about that because he knows it's pretty difficult. But what I'm going to do is I'm going to clear the screen and show you guys on Desmos. So I'll pull up some Desmos here. Here's Desmos. And, well, what was the equation? X cubed minus 6x squared. Y equals x cubed minus 6x squared. And I need a minus 6x squared. And then was it plus 9x? Plus 1. Plus 9x plus 1. Alright, so if you guys will take a look, this is the original function. Notice it's increasing from negative infinity to 1. That's that coordinate 1 where it's increasing. It's decreasing between 1 and 3. There's that x coordinate. And then increasing one more time from 3 all the way to infinity. Notice also here's our maximum at x equals 1, and here's our minimum at x equals 3. And so there you have it. That's our original polynomial. That's the function. And we were able to figure out all the pieces without using the calculator, which is pretty exciting. All right, let's see. I can always try another one, but these are all going to be very similar. Maybe I can try like number 5, since that one's a 4th power. Let's try number 5. Let's see. Given x to the 4th minus 8x squared plus 3, we want to find the derivative. Because remember, set the derivative equal to 0. So it's 4x cubed minus 16x. So let's take the factors of that. They both have a 4x in common, and we're left with x squared minus 4. Now we're going to factor x squared minus 4. That's the difference of squares. So that's x minus 2 and x plus 2. And a 4x in the front. Remember, we have to set it equal to 0, so we need to find all the zeros. So we have this one is x equals 0. This one is x equals 2. And this one is x equals negative 2. And we're going to put those values on the number line. So I got negative 2, I got 0, and I got 2. All right. Next thing we're going to do is plot some values, like maybe negative 1. What happens when I plug in negative 1? That's negative 4. Negative times negative is positive, so negative 4 plus 16 is a positive value. So this is positive. What happens when I plug in positive 1? Well, that's positive 4 minus 16. That's negative. Negative. What happens when I plug in 3? 3 cubed is 27 times 4 minus 16 times 3. I'm going to use my cheat sheet, which is my calculator. I know they said don't use a calculator, but I just want to double check. 4 times 27, 108, minus 16 times 3, it's going to be positive 48. So that's going to be a positive number. Usually they do alternate like this, so I'm going to go ahead and tell you that this one will be negative. Negative, positive, negative, positive. So where is it increasing? Increasing from negative 2 to 0, union, again increasing to infinity. Where is it decreasing? Negative infinity to negative 2, union 0 to 2. And then again, you can tell where the minimum is. There's 2 minimums. The min is at x equals negative 2 and positive 2. And the max is at x equals 0. Now negative 1 falls into this interval, meaning it is increasing in that interval. And I'm going to stop there before my time runs up. Again, keep practicing and hope to see you guys soon. Bye.